Now it's
You had the...
yes, I have.
Sorry.
Okay, well, good morning, everyone. Just close everything. Yes. Today is day 11 of the Solidity Bootcamp, and we are going for the challenge number 5, I think. And today is about state channels. And I just learned about this. I know there are some different ways to scale the blockchain. One of them is layer 2s, the other one rollups, yes, everything. Everything to take the transactions off of the main chain and execute transactions on side chains or other machines, and then send the updated states to the main chain. Right? This is the way that scaling, at least for Ethereum, works. Vitalik has talked about layer 2s, layer 3s, layer 4. So this is the way that he thinks that we should scale the blockchain, right? And state channels was an early approach. This is useful for when you want to interaction in real time for two users, and then just move the final state to the main blockchain, right? And we're gonna do this exercise today, which is about a little guru, may I say? Yes. There's a person, there's a user, and there's a guru that wants to receive. The person wants to receive some wisdom from the guru. So he's gonna receive some payment for his wisdom, and the user is gonna just receive the wisdom, right? There's two users in this application. And the different thing about this is that this is not done on chain, right? Because if we did this on chain, we had to send every update that the guru sends, every word or character that the guru sends should be a transaction. But we are just going to have the user deposit some ETH, and then the guru is going to send the words or the wisdom, and for each word he's going to charge an amount of ETH, and depending on this amount of ETH, at the end of the wisdom given, he's going to receive this payment from the user. So there's only two transactions in the chain: the deposit and then withdrawal, right? And then all of the other interactions are going to happen off chain. I guess this is the exercise today. Okay, so let's start. Oh yeah, the document. I'm going to share this document again so that you can paste the commands.
So is the off-chain interactions ever happening just on the front end?
Yes. Just front end updates, state updates, and then just finalize it with one transaction. Steps. Okay, so I shared the link already in the Discord, and then you can follow if you don't have access to this, which I know some of you don't still. You can read some more about the state channels in here. There's an article pretty interesting here, and there's also something about the ECDSA libraries, but we're not going to use them for now. This one is an interesting reading. I'm going to send it as well. Okay. let's just go ahead and clone the repo. Gonna paste all of this here. Okay.
Can you put the link of the ESDCA?
Oh, yes.
Oh,
This one, right?
yeah.
Yeah, that's an interesting library, but they decided not to use the functions from the library, just code it from scratch. And I don't know, it's maybe it's just to understand how the functions in the library work. So, and if you ask me, I think it's a little bit too complicated, but they just went for it. Okay, so now that we have the repo cloned, we can, we install the dependencies, and we're gonna start our chain, our local chain, right, with yarn chain. So you just go to your terminal, yarn chain, and then you have your local node running. Bless you. Then in a new window, we're gonna deploy our contracts for the first time. So this is gonna be yarn deploy. Okay. Nice. Well, let me close everything here. And in a new window, we're gonna start the interface. Okay, so we already have the interface here, and we can see that on the debug contracts tab, we have just we should just have one contract, which is the streamer one, and this streamer contract is going to have all these functions. We want to work on the functions that that allow us to do this. I don't know, this interaction off-chain and just have the updated states in on-chain, right? So for the first checkpoint, we're gonna start with the, oh yes, here it says a little bit about the ownable standard. We already know about the ownable standard. we need this contract to be ownable so that the owner of the contract can withdraw some funds to the wallet address. Okay. So yes, our contract, the main contract, the streamer contract, will inherit functionality from the ownable contract from OpenZeppelin, right? And we can do this with just oh yes, let me just open the code editor from scratch. Here, nice. We can navigate to our streamer contract, and we can see the comments on the functions and everything in here, right? Right from the start, we have the streamer is ownable, and this is the way that we're doing inheriting the functionality from OpenZeppelin, the ownable contract from OpenZeppelin, here. Let me see if we have a only owner, no, not yet. So we're gonna use it later. But for now, we just have the functionality here. Okay, so then it moves just uncomment the lines to deploy this the contract and to transfer the ownership of the streamer contract to the front-end address. So we're gonna navigate to, let me just write it here, navigate to deploy contracts. Okay. Yeah, and we're just gonna go to the deploy script and deploy streamer and uncomment these lines of code over here, checkpoint 1, right? So we just select this and just control plus a slash, and then you're getting this. We're getting a warning that we cannot find streamer, so we just import the streamer over here. We already have the line here, we can just uncomment this. Good. Now you can see that this is just calling the transfer ownership. Yeah, this is getting the contract, the address of the deployed contract, and then just transferring the ownership of this contract to the front-end address. So here we're gonna paste our front-end address that should be in the localhost 3000 tab. Here, copy address. Oh yes. Okay. And then just paste it here. Oops. Nice. We can test this one with the yarn deploy again. Should be, yeah. Okay, ownership transferred successfully. And now I can see that the owner of this streamer contract is the front-end address. Now it has not updated, so I just, yes, you can see that the owner of the contract is the front-end address. Same address, right? Oh yeah, I forgot to, okay, now it's better. Yes, and like we said, we're gonna need 2 users for this, so you can just control click here on the logo, and it's gonna open up a new tab with a new address. As you can see, this is a different address from this one, so we can interact with each other from these 2 separate tabs, right? Different addresses. And if we go to the streamer tab here, we should check that one of our addresses, which is the addresses we pasted, is going to be the guru, and then the other address is going to be the root. I don't know what a root is. I think it's a person who receives some wisdom, so like a monk. But yeah, I guess one of these is going to be the one sending the wisdom, and this is going to be the one receiving the wisdom, right? Yes, we can grab some funds already from the faucet. You can put that yourself as well. And now both of our addresses have some ETH. I'm going to write this one here. Yes. So now we're going to work on this, on opening the channel. And we can read more about this here. Let me just, yes. So for this to work, or for the interaction to work between both users, we're going to have like channels, yeah? This is the exercise, what the exercise about, the channels. And to start a channel, we're gonna work on this function called fund channel. The fund channel is gonna receive some ETH, and it's gonna update the balance of the user that sent the transaction. And this is gonna allow the guru, the one that's gonna send the message, to see which channels are open, and to send message through this channel, or to use this channel as the starting point, yeah, and then finalize a state on this channel. I guess this is the way that it works. So we're gonna go to the streamer.sol contract and just work on the fund channel. So navigate to streamer.sol. Okay, and we have the fund channel here. Fund channel is easy. We just have to revert if message.sender has already a running channel, which means that the channel is already open. So we're going to require that the balance from this sender, from the user, is different than is just zero. It has no balance, basically, the channel. So we start with the require function. Require. Oh, it already suggests this. Nice. I'm gonna paste this one, or maybe I just paste the whole function at the end. Okay, so now that we revert if the channel is already open, we can open a new channel, right? And we do this by founding the channel with the message.value. We're just updating the balances mapping, which is here, and setting the value to message.value for the user, for the sender. Okay, and it finally says just emit an open event. We have some events here. You can see open, challenge, withdrawn, closed. So we're just gonna emit the open event. Emit open, okay, with message.sender and message.value. Now remember that this function, to receive Ether, it's gonna have to be payable. So this one is important. Okay, let's move on. And then we're gonna just navigate to the root.tss. Oh yeah, let me just paste this code in the guide. Go to okay, there you have it. Then we're going to go to the interface page, the root page, which is this one here. and just uncomment the functionality for the button to work. And we're gonna go to Control P, group.tsx, and we scroll down, and we're just gonna find the okay, now it's already uncommented, so you can see here is where the interface calls the font channel method here, line 208. And then it just sends a ETH value of 0.5, and this is the way that this button is working here, right? So we just inspected it. We can try this already. We have our function, so we can just deploy our contracts again and try this one. It's updating the interfaces. Okay, so we have our guru and our root, and we're just gonna send 0.5 ETH. Oh, I should have some more ETH. Let me just grab some more ETH. Okay, so now my transaction is completed, and I can see the interface changed. So now I have a field here, which is it's gonna be where I received the wisdom from the guru, and now the guru should have a new field, which is gonna be where I send the wisdom to the rules, right? So this is already changing, and nice. We can just move on and then work on the functionality now. Yes, so everything here is complete, right? Yes. So now that the channel is funded and everyone has observed that there's a new channel open because it updates the interface, right? This is done on observing the events. And now we can just move on to working on the components from the page, right? Here on page.tsx, we can navigate to this one. Let me paste it here. No, streamer. So in packages, next app streamer page, we're going to have this file here, right? And here it asks us to inspect the provide service, the reimburse service, and the process voucher functions. In the provide service, the guru is going to send some wisdom over the wire to the client. In the reimburse service, the root is going to create a voucher, and then for the receive service, he's going to assign this voucher, and then he's going to return it. And here is like the core function, the process voucher, where the service provider is going to receive and store the vouchers. We will work now on the process voucher, so which is where the service provider examines the returned payments and confirms the authenticity, and just store the payment. So let's go to yes, process voucher. We can just Control F, process voucher. It's not here. Oh, this one is going to be in the, we have two different files, one for the guru and one for the root, which should be these different interfaces here, right? We're going to go to the guru one, which is the guru.tsx. And we're going to see that we have already here the provide service function, which is done, and then the receive voucher function, which is already done as well, and we're going to work on the process voucher function. this one here. Okay, I'm gonna open up the root file as well so that we can see how the functions are working. The root file is here, and we're gonna inspect this reimburse service. So in guru.tsx, we're asked to recreate the packed hashed and verified message from reimburse service, which is this function over here, right? So we're gonna recreate these three variables. Here I'm just gonna copy and paste these ones here. Okay. And what this is doing is just encoding on a string with the same values that we used for the reimburse service here. So we are using the updated balance, which should be the initial balance subtracted by the due payment. We are using the packed one, which is the encode string. We're just hashing this string and then sending that to bytes with the 2 bytes function. And we're doing the same thing here in the guru file. Okay, let me just enter. I'm gonna paste this as well in the guide. Okay, so now that we have these three variables, we're going to use this verified function to variable to send to verify that the user who funded the channel is the one authenticated with this signature. So we're going to use this verified message, which is from the library, the Vim library over here. Yes, and just verify that the user who funded the channel is authentic, right? So we're going to have the verified message here. And this one receives 3 parameters: address, message, and signature. And I'm just going to grab this from the project that I did before this lesson. And let me just see where it is. No. Guru.tsx. Okay, I'm going to paste this in the guide as well, and I'm going to try to explain it again because I didn't even understand myself. Let me see, where is it? Okay. Guru.tsx and Yeah, so there you have it here. Let me just go back and try to explain this from a little earlier point. So provide service, reimburse service, provide. And process voucher. Okay, so to go back a little bit, what we're doing right now is just from the RUB interface or the RUB address, he's just sending 0.5 ETH to the contract, to the streamer contract, and then this is signed with a transaction, right? And this transaction, this sign, this signature, is going to be verified by the guru here. And he's going to start sending the wisdom once he verifies the signature. And he's going to use also the signature to get the address of the person that opened the channel, in this case, the root. For this, they're using like the encode packed functions, which is going to encode everything, including the balance. And then the guru is going to just try to replicate this encoding and return the address as well. So here he's gonna, yes, the provide service is just a function where the guru sends the wisdom. It's just updating the wisdom and updating the balance that he's gonna claim as his. Because here, I don't know if we can just test it right now. Hey, I am saying yes. So this is being run by the provide service. The provide service. It's just updating the text and then updating the balance that the guru should receive after finalizing the channel. The other function, the reimburse service, is where the other user, the one that receives the wisdom, is creating a voucher and then signing it and returning it. So this is the signing part that I mentioned. And then from the guru side, the one sending the wisdom, we have the process voucher function. And this function, the service provider receives and stores the vouchers. So this is going to be where he gets the signature, he encodes it the same way, and just use the values to verify that the user is the one that sent the signature with this verify message here. this one here. It's a little complicated. I'm gonna try to do a diagram and just send the diagram to the Discord channel as well, so that we can all have a clear idea on that.
Are you gonna share the GitHub for this? Your own
Yes. I think I shared the link before, but I have not updated the repo, so I'm just gonna try to update as well. Yeah. And if the voucher signature is not valid, we're just gonna return the function and not do anything. But if it is valid, and then we're gonna just set this new voucher inside the vouchers array and then process the voucher. So this is what this is doing. We're just gonna move on to the next part. Yeah, so the same thing that I said already, it's here. You need to recreate the encoded message that the client has signed and then verify that the received signature was in fact produced by the client on that same data. So you have that here. Oh, we have already tested this, which is writing some wisdom here, and just it updates the balance here. This is entirely off-chain, yes. This is there are no transactions involved in here.
But does the mainnet, do they get the message that was here or not even? They just get information about the message?
No, they just have what the mainnet has right now is just the log value of 0.5 ETH and the state of the open channel, that a channel is open. And then after we reimburse the voucher, then we're gonna just send this amount of Ether to the guru and then set the channel as closed. Yes. Those are the only the transactions on chain. Yeah. There's a little side quest here that we're not gonna do because of time reasons, but you can just prevent continued service to clients who haven't paid, basically. So you wanna there's a hint over here. And I'm gonna try to do that as well and just send it in the Discord channel or in the repo. But checkpoint 4 is about recovering the guru's earned service. So everything that's here, just transferring to the guru and then finalizing the channel. Now that we've collected some vouchers, we'd like to redeem the on-chain and move funds from the streamer to the guru's own address, right? This is gonna be with the withdraw earnings function that we have over here in the streamer.sol. So let's navigate to streamer.sol. And then we're gonna work on this withdraw function, withdraw earnings. Withdraw earnings. Okay, so you can see that here we are receiving all data from the voucher, and one of the data in the voucher is just the updated balance, which is this one here. Okay, so with that hashed, with the kcat256 function, we're gonna encode it and then just use this one for the recovering the earnings. I'm gonna grab this one from my previous work. Let me see, it's over here. Okay. Yes, here. And we can see it here. We are using the eRecover function, which is the a Solidity one, and then just getting the client address from this, because we are sending in the voucher object, we are sending this signature, so we are recovering from the voucher object these variables here. These are just from the structure of the transaction itself. We are recovering the V, the R, the S values, and then using this with the recover function to get the client address, the one that signed this transaction or that opened this channel. And now we're just gonna have a require function that is gonna check that the channel is still open with this, and that the balance of the client address is greater than the updated balance, which means the client has sent or has logged more ETH than the guru has sent. Because if the client just sent 0.5 ETH and the guru has written a message like crazy words, oops, the transaction should fail, because he should be getting more ETH than 0.5, right? It makes sense. So that's why this requires here. And then we're gonna start calculating the payment, which is gonna be using the updated balance, and then this payment is gonna be sent to the owner of the contract, which is the guru, right? With the call function. And if this sending is failing, we just revert the transaction. And that's it, and we just emit the withdrawn event, which is over here up the top. I don't know if I paste this already. Let me see. Oh yes, paste this in the withdraw function. Okay. Yes. There's a little bit more detail about these values, VRS, in the eRecover function here, recover function guide. I'm gonna send this one as well, so that you can read it after this. Okay. From a signature using eRecover. Okay. Yes, and I have already explained how to send the balance to the owner of the contract, which is the guru. We can test this one now with the yarn deploy reset, and just go for it. Let me get yarn deploy reset. Oh, and we should uncomment the withdraw button, which is going to be in guru.tsx. It's going to be here. Yes, here.
The link you just sent, it's not about e-recovery.
Oh yeah, you're right. Encode path. No. Let me search over here. Yeah, I think this one's better. I'm gonna just send this because here it explains the values R, S, and V. Okay. Thanks. Okay, so let's try the withdraw earnings after we have sent some wisdom. Let me see if we. Yeah, we have the cash out latest voucher, which is going to be this channel. And now I should have 0.5 ETH more. Let me see if I get that. I'll try again from the start just to see if it was something with the owner address or something. Let me see, reset, and just get okay. I guess it's working, but I'm gonna check it out because I don't know why my balance is not updating. Might be something with the address. I'm just gonna try to see, and if not, we're just gonna complete the challenge with the next functions and see if it corrects the issue.
My work.
You have your balance updated? Nice. Okay, let's just move on, and then I'll check out what I did wrong with the Anderson code. Okay, so yeah, so far so good. It says here groups can connect to the guru via an on-chain deposit, the 0.5 ETH. Then the pair can then transact off-chain just from state updates in the front end with high throughput, right? This is usually used like in games, for example, when you need a game, online game where two people connect and interact, and they have tons of transactions that you cannot do on chain, and then you just deposit one amount of ETH and then work off chain with this amount of ETH and then just reimburse this amount after the transactions have happened. Yeah, and here the guru can recover earnings with the received vouchers, and vouchers are like the way that state channels work in this exercise. They just call them vouchers, and the voucher is going to have all the data from the transaction, the updated balances, which is the most important data in this exercise, the amount of ETH that the guru should receive. He says, but what if a group is unimpressed with the service and wishes to close a channel to recover whatever funds remain? What if the guru is a no-show after initial channel funding deposit? So this is everything just to protect the user that is receiving the wisdom to receive good wisdom, let's say. Or if he's satisfied with the service, or if he's unsatisfied with the service, he can challenge the transaction and just receive what he has received so far from the wisdom and finalize the channel, the state channel. A payment channel is a cryptocurrency protocol. Yeah, so we need to take care of the financial interests from the users, right? So because of this, we're going to implement a challenge and close mechanism that allows groups to recover unspent funds. I don't know what time is the other lecture. What time is it? Okay, nice. Thank you. Yes, so with this we can just allow Rubies to recover unspent funds, but we are keeping the guru's earnings safe. So we are sure that he receives some earnings, even if he's sending just bad wisdom. Right? We're going to navigate to the streamer contract here, streamer.sol, and then create that challenge channel function. Okay, challenge channel. And you have the steps over here. The challenge channel is gonna just, oh, sorry. Yeah, it's gonna check that the message.sender has an open channel, like this. It's going to update this mapping, can close at message.sender to some future time. Let's say that we're just going to have like 30 seconds here. And then it's going to meet the event, the challenge event here, over here.
And the reason we gave it initially 10 minutes is because, like, to allow all the blocks to
yeah, like 10 minutes is a more reasonable time just for the blockchain in the mainnet, yes. But for this exercise, we can just go for 30 seconds to update the state faster, basically. And okay. Oh, Anderson, do you have this required like this? Yes, do you have the same here? Can you check, please? Maybe I did hit something wrong here.
On the channel, the balance is
Okay, nice.
So only the message is different.
Nice. I'm gonna check after them. Okay, let me see if I'm correct with what I did, because I have my guide here. Yes. Okay, let's go.
Your guru has money? As if?
Sorry?
Your guru has if? When you try to do the streaming, your guru has if?
Yes, you should have some ETH. Yes, yes.
So, okay.
Yeah, and then we're just gonna uncomment some lines of code in the interface for the root. So this is gonna be here, root. We can search for the, I don't know, challenge. Let me see, challenge and closer. Yes. So we're gonna uncomment this block here and here. Okay, let me see this little warning here. Okay, so just some typing mismatch. Let me see what else. No, I think that's it for this interface. Let's go. The challenge channel function should check the balances map that the channel is already open, and then in the name of message.sender, we have done that with the require here, right? Here. Then we declare this channel to be closing by setting can close at to block timestamp plus 30 plus seconds. Here it says 30 seconds we should use because of working on local, but if we are doing mainnet or testnet even, we can just use some more time. And then we emit the challenge event, which is here, right? Okay, the emitted event gives notice to the guru that the channel will soon be emptied. So they should apply whatever vouchers they have before the timeout period ends. So the timeout is going to be displayed for the guru to claim the earnings, because he's going to have this button enabled just for 30 seconds here. So this is the timing that's using here. Okay, we're gonna see this in action right now. Let me see if I'm missing something. Okay, so here it says we should work on the default channel here, which is gonna be, this default channel is gonna check that the message.sender has a channel that can be closed. Yes, using the can close at mapping. Then it's going to transfer the balances to the sender, right, from the message sender, and then it's going to be a closed event. This is going to close the channel. We're going to work on that right now and navigate to streamer.sol, and here we have the default channel function. So we can go just function default channel public, check that message.sender has a closing channel, which is done with this. Okay, can close that and can close that. Then it checks that the current time is later than the closing time. It's also doing that here. And it sends the channel's remaining funds to the message.sender and sets the balance to 0. So this is going to be with the call transfer. Yes. Let me see, because I have it here. Okay. So with the call function, it's going to send the balance to the message.sender, and yeah, then it's going to revert if the transfer failed, right? And it's going to update the balances and just emit the closed event. So this is what this function does. And as you can see, the state of the channel is being updated with this can close at mapping, and this is used for all the checks that we have on the challenge and the default channel. So we have done all of this, and then let's try and test this one out by redeploying our contracts. Okay, so yarn deploy, reset. I'm gonna paste the code that I forgot to paste here. Okay, so in summary, the user is going to call this challenge channel function from the contract, the streamer contract, and this is going to warn the guru that he has to claim the funds because the user is unsatisfied with the service or some kind. And then the guru is going to call the default channel to receive the ETH that he has provided with the wisdom, right? So this is what these functions are for, just on the basics. Okay, so let's try. Let's see if it works, hopefully. If not, we can try Anderson's version, which I think it's working already. So let's go. I will try to refresh this. Let me try from scratch and see if I can update the front-end address as well. Let me just close everything and start with a fresh new open channel. Okay, let's see. Yeah, I forgot to update the front-end address. I'm gonna copy my front-end address and then just paste it in the deploy scripts again, as we did it. Deploy streamer, paste the address here, which is not the same, already changed. And then this is gonna be my guru. And then I'm gonna open a new one, and this one's gonna be the user. Okay. Let's redeploy again, now with the front-end address updated. Update. Okay, so the owner hasn't changed. I have no idea what's going on. I should have the owner like this front-end address. I don't know what happened, but I guess I can try and fix this after class, and then just send the updated repo to you. Yeah, because right now I cannot do the test for the different users with the channels. I guess these functions are correct. I'm gonna try these ones as well and just see if they work, the contract functions, and try to correct this issue with the deployment, which is.
Maybe you can try restart the chain.
Oh, that works for you, right? Sometimes. Yeah.
Sometimes works.
Okay, let's try it. Violet's giving the lecture right now. Yes. Okay, let's try. Paste the address here. And redeploy. Now it's worse. I don't know. I'm just gonna try to figure it out and just send the solution in the repo and just send the repo link. I don't know what happened.
The wallet is the same?
Yeah, it should be the same, 0x8a and not this one here. You see? Okay, so I'm sorry for that, and I'm just gonna send the Discord in the Discord, send the repo link and then the diagram as well, so that we can understand the flow of the state channels, or how state channels work. Okay, and any question you have, you can contact me in Discord, or I'm over here as well. And I hope you have a great time on the next lecture. She's already waiting. Thank you. Thank you.